Hi everybody, welcome to week 5. Well, in our previous learning modules, we've taken more of a 30,000 foot view of information management, and we've looked at major processes in information life cycles and information workflow, very much the big picture view of organizational information management using digital data. This week we're going to dive down and take a more microscopic view of information management in an area that is most often overlooked in terms of information workflow design and implementation. Now, this area involves a variety of tasks and standards and practices. We're going to call it file management for lack of a better term. But essentially, file management includes and encompasses the rules and standards and various practices that we implement at the lowest level to ensure that our data files, meaning our content, is properly organized and accessible to those who create, distribute, and archive it. Now, probably, and in my own experience, 9 out of 10 information management problems involve poor file management in one form or another. And when we talk about file management, there's a wide variety of different resources and concepts that we need to talk about. Poor file management could stem from lack of enough online storage space for content producers to be able to create files that they need for their work. It could be lack of standards in how the content is structured in the files, or what the quality, the resolution, or the format of the files are, how the files are named and how they're stored, where they're stored, and who has access to the storage. So we have a whole landscape of different issues to talk about. Good file management practices, on the other hand, definitely improve an organization's productivity. It improves how rapidly information can be produced and disseminated to end users. It makes archiving old information much easier, and it makes accessing current information much more rapid and easier for end users. Good file management also has a positive impact on our IT resources. That's because files are distributed properly, they're stored in the correct places. Large files, we know where they're going to be stored, and they are stored on faster disks as opposed to small files, which can be stored on slower disks. We ensure that there's enough storage space for everybody, and that everybody has proper access and knows where to look to retrieve files. And when we talk about having proper access to files, we should also mention that it's not only individual access to files, like individuals through their computers, but also information systems have appropriate access to files is a consideration we need to look at. This is entitled The Secret Life of Files, this diagram. What we could more properly consider it to be is a file lifespan diagram. Every set of files, as opposed to the content that's in the files, files go through various stages of generation, distribution, and then archiving that we need to consider separately from the higher conceptual view of the information lifecycle. The information lifecycle governs how an organization deals with larger scale information issues file management is what the average information worker has to deal with in order to find a place to create their files, ensure that they're using the right applications to generate the files at the proper quality, resolution, and format, and that the files can be passed from one worker to another in the easiest possible manner. We're going to look at this diagram in some detail later in the lecture, so I won't spend any more time on it right now. But let's talk about the lowest level of a computer operating system that we interact with, which would be the file system, for a moment. Now, contemporary file systems for computer systems is very different nowadays than it was in the early days of computing, in a couple of very advantageous ways that we are able to use. File systems are distinct services that an operating system provides, and file systems can be mounted on a variety of storage media. So there could be, most likely you're going to be interfacing with hard drive storage, but it could also be disk and tape. In order for us to store data on any kind of storage media, it has to have a file system mounted on it. That's why we have to format disks for access by specific types of systems, whether that's a CD or DVD disk or a hard disk. The same thing with tape. The file system manages the access to and the storage allocation of files on the storage media. Now, storage media in information technology terminology can also be called mass storage. And one of the distinctions we need to make between the different kinds of storage on a computer system is between volatile storage, which we call memory, and that would be your RAM, or your random access memory, or various forms of cache that are either on your motherboard or that are attached to network cards or to video cards, audio and video cards, for example. Mass storage is permanent storage, and that's either on a disk, tape, or a hard disk, or a magnetic storage media like a flash drive. In the early days of computing, managing the file system was a major task of the operating system. And there was a lot of human-computer interaction required to properly store data on disk or tape. Today, disk management and file system management is pretty much handled behind the scenes. The end user of a file system today sees a virtual display of the computer's attached storage devices that allows us to easily interact and create folders or directories in order to store individual files. Prior to the 1980s, file systems had to be managed manually. In fact, the first personal computer I had, you actually had to determine what blocks were free on a floppy disk in order to place and store a file on the floppy disk, and there was a variety of commands that had to be made manually to tell the computer where to store something on any disk and then how to retrieve it again. It certainly wasn't an easy set of procedures at that point. Nowadays, we more properly only have to deal with file management in terms of conceptual organization of data rather than physical organization on a computing system storage array. As I mentioned, in the early days of computing, this is a diagram from the late 60s of a, I think it's a mini frame. It's not big enough to be quite a mainframe, I think. But essentially, if you notice in the top corner here, we've got a disk storage unit that is a separate entity from the major computing resources here. We've also got magnetic tape storage. In these older systems, there was actually no file system as we think of it today. These systems dealt with direct data storage to a storage media, which had to be planned and organized way in advance of running a program. Storage was often linear, so you simply started at one end of the tape and added bits until the end of the tape. So the capability of file management in early systems was very minimal indeed, and had to be it was quite labor intensive to plan and implement data storage. A breakthrough that started in the 60s and really didn't come about till the very early 70s, when Dennis Ritchie made his UNIX operating system available to academic institutions for research computing. The first real contemporary file system, as we think of it today, was called UNIX. There were several variants of it early on and several predecessors to it. One was called Multics. The UNIX system actually provided a text interface that displayed the data on a storage device in a way that was not, as you can see here, not the easiest in the world to navigate, but certainly provided a revolution in terms of human access to storage, file system on a storage device, and provided the means through utilities to create files, to move them, to organize them in directories and subdirectories, and to transform them with simple command line interface commands. From Unix developed what we call the disk operating system, DOS, and again there were various flavors of DOS that were available depending on the computer platform and what kind of products you were using. My first computer was a Commodore back in the early 80s, and it had its own proprietary file system, which you can see little screenshots of here. Commodore had its own variant of an operating system. Apple had its own variant, which is originally termed HFS. It's a term that's still used in information technology, but hierarchical file system is what that HFS stands for. And then Microsoft and IBM went in together to develop the modern disk operating system, which is the basis under which current Windows systems run today. There were two distinct versions of DOS. IBM split from Microsoft after their initial collaboration, and for years has maintained its own version called PC-DOS, and Microsoft went on to maintain its own version called MS-DOS. DOS is very much like Unix in that it provides a text-only interface to show files and directories on the operating system. The Also the utilities that are used to create, move, and transform files are also command line driven, and they tend to be fairly similar even among different early variants of the operating system. Commands like move and copy are similar from going from UNIX originally through to the disk operating system era in the early 80s. Later on, after sort of the beginning of the personal computing revolution, it was obvious that end users wanted an easier way to use their computers and manipulate files and access the file system. So both Apple and Apple first, obviously, and Microsoft developed their own graphical user interfaces. Now, my primary experience is more on the Microsoft side for obvious reasons, but I think the first GUI system that I ever got to use was an Apple interface, and it was very much like the Microsoft Windows 3.0 interface. Provides a shell, sort of a graphic shell, that sits above the disk operating system and is sort of an intermediary that allows the user to interact with the file system in a visually pleasing manner using a mouse and drag and drop it, etc., as opposed to using a command line interface. There were also, at that point, alternate graphical user interfaces that provided very nice file management capabilities. Now, for Unix-based systems in the academic world, a graphical user interface called X Windows was developed. And the X Windows was not really used in the business environment or in mainstream education. It was often used by computer researchers and scientists and so forth at high-tech labs and so forth. And X Windows never really took off as a mainstream graphical user interface system. IBM, still feuding with Microsoft towards the end of the 80s, created OS2. That was actually, again, it began very early on as a collaboration between IBM and Microsoft, and they once again split on the project, and Microsoft went on to develop Windows, and IBM tried to develop and market OS2, which provided both a disk operating system based on PC-DOS and then a graphical operating system that looked very much like Windows. In many ways, OS2 was a much superior graphical user interface to either Apple or Microsoft. It just never got much market share and has kind of died off. In fact, I don't even know if IBM offers OS2 as an operating system platform anymore. Through the 90s and the 2000s, we've had I wouldn't say a revolution, but we've had major enhancements in how graphical user systems let us interface with the file system to perform file management. The current versions of the three most popular operating systems are certainly Mac OS X Mountain Lion, Windows 8, which was recently released, and I think was roughshod enough that everybody who's using Windows 8 is looking forward to Windows 8.1. And then Ubuntu 12, which is a graphical user interface that's open source and free and runs on top of the Linux file system. So if you want completely free operating system for your laptop or desktop computer, Linux and a free version of Linux and Ubuntu are the way to go. Windows 8 and OS X are the most sophisticated operating systems, and they provide the most features for good file management. Ubuntu lags behind because it's extremely new. It's just a few years old, really. And however, it is very popular amongst people who like open source software. Some of the characteristics of contemporary file systems is that they are what we call virtualized. Basic virtualized file system is a good thing. Some file systems and applications that store files get a little carried away with virtualization, and that's something we'll talk about in a little bit later on. But essentially, the file system is presented to us in a hierarchical manner where we have a root directory at the top and subdirectories that branch out beneath that in which we store files. This is not actually how files are stored on a disk. In fact, files are stored all over a disk to maximize disk storage space, which leads to what we call defragmenting. Once you start deleting files and moving them, it leaves holes in the disks, which are blank spaces that need to be filled. And then eventually the files start getting split, and one piece gets put over here and one piece gets put over there. And the disk will defragment and become slower in operation than if the disk was optimized. So that's why it's important to defragment your hard drive regularly. There are some utilities and some operating systems that provide automatic defragmentation. In addition to this virtual hierarchical view of the operating system, which is easy for us to comprehend, modern file systems also include extended types of file properties, and some of these are inserted into the files automatically by programs that we use or by the operating system itself. So the date and time, for example, that a file was last accessed or last modified is automatically updated by the file system. Other extended file properties include tags and metadata fields and so forth that we can make use of to better document files and to provide better searching and retrieval of files on the file system. Now, these extended file properties are usually not accessed automatically by the applications that we use to create, view, and modify files. So a lot of times a good file manager needs to do some basic tagging of files for search and retrieval that is going to be outside of an application that we use to normally view the files. So for example, in Microsoft Word or OpenOffice Word, even, the OpenOffice Word processor, you can access some additional metadata fields through those applications, but there are also tagging capabilities in both like the Mac and Windows operating systems that let us insert metadata into word processing documents so that the search engine that we use on top of our file system can more easily find the files. One of these features in modern Windows machines is called a tag. And a tag can simply be a keyword, or it can be any sort of notation that allows you to search quickly for file system information and retrieve a set of unique files. Directories are more and more able to handle extended metadata, and that's important so that when searching for files, that we can point out unique properties of batches of files through an extended metadata in the directory that contains the files. We also have a lot of tools. In fact, you'll get to use some this week in your tools and methods assignment for managing files, naming, batch naming, batch renaming, batch moving of files from one location to another. Nowadays, content in computer files can get extremely overblown quickly. Word document can get to be quite large size if you insert pictures, certainly, or if you into a slide presentation insert a video clip, and then certainly digital media files like streaming audio and video are extraordinarily large by contrast to their text counterparts. And so having tools and utilities that help us move very large files has become more and more important over the years. So let's talk about some general file management methodologies that can help you in organizing and maintaining content at whatever organization you're working at. You should take advantage of those file system features in Windows or the Mac OS X or Ubuntu, for example, that provide extended metadata and properties for files and directories. File management is often a team-based activity in an organization, meaning that in the workflow from creation to dissemination of a piece of digital information, whether it's a text-based report or an audio or video clip, multiple individuals are going to need to modify and convert files, edit them, and prepare them for publication or distribution. So having a common set of rules for naming files, storing files, moving files, etc., is extraordinarily important to keep an organization in a highly productive mode of creating and disseminating digital information. Naming rules, of course, should govern both individual file names and should govern how directories are organized and named. Let's talk about naming here for a second. File naming is one of the most sort of underappreciated practices for digital information management that I usually find. Both in our personal lives and in our work lives, we find various, different kinds of variations in file naming just between, departments in an organization. File naming should be something that's enforced on an entire organization from the top down. So it's something that's important so that everybody understands how to read file names when they're looking at them on, through the file system interface. It's important that files are named so they can be sorted and so that you know what content and what type of content and all of the major bits of information that one needs to know before taking the trouble to opening a digital file are. Some of those can be simply a content indicator of what's inside. So this is an annual report being that I've got here as an example on the slide. We can do several different types of naming that provides good sorting and good visual recognition and retrieval of the files. So the first abbreviated version, annual report, shows the simply removing the vowels out of the words annual and report, and that's a good way of compressing file names so they can still be pretty much understood. The mnemonic method is to create a set of standard abbreviations that represent common words used in file names, so AN for annual and RP for report. A classified arrangement puts the file name in a sort order so that when you have 1,000 files in a directory, that you can easily scan and find a specific file because of the way the name is organized. So the classified file name example here will sort all reports together of any kind, annual, semi-annual, financial, personnel, etc. And then the type of report, annual, and then the year of the report was issued. Classified arrangement is extremely useful for large file systems with many files that many users have to access. Dated file system, file names. It's kind of a natural impulse when we're naming a file to put the date at the end. But unless you have a lot of common files that you need to sort by date, common types, so like report 1, report 2, report 3, so then sorted by date, it's always better to put the file, the date indicator at the beginning of the file name as opposed to the end. And then by using the ISO standard year, month, day formatting allows the files to be sorted by date, by year, month, day, whereas if we sort them by month, day, year, everything in 1 month is going to sort together regardless of year. And that makes it more difficult to look at files in a directory and that are date sorted. So using a specific ISO date format, using a classified arrangement to group like kinds of content together, those are important concepts in developing good file naming conventions. The other thing we see a lot of sort of mishandling with files is indicating a version. When I worked in the media industry and we had photo editors and audio specialists, who were creating tons of files a day, usually had to go back and edit files, the files on multiple occasions before a project was finished, and it was funny to look at the kind of weird ways that they tried to indicate version or status of a file. So instead of indicating that something is version 1, 2, 3, often we would see that something was, like audio clip, final, audio clip, final, audio clip, really final, that were sort of ad hoc implementations of a status or a version of a file. So if you are going to, in a file production, content production workflow, deal with multiple versions that have to be edited and approved and then re-edited and so forth, having a good version and status naming convention for the files is very important. As I mentioned, using extended properties in the file system, such as the tag field, custom metadata fields that you can access, for example, in Microsoft Office. Also other types of applications. It varies greatly between applications, so I can't give you easily give you a list, but for research data management, many qualitative and quantitative data management programs enable you to create custom metadata tags in a project file. So it varies from application to application. The one thing to be cognizant of, and sort of the caveat about using extended metadata properties for files, is that a lot of times custom metadata fields and tags and so forth get stripped off of a file when it's moved off of one server across the network and put onto another server. Now, these custom metadata properties are fine when a file is being stored and just moved locally on one contiguous, disk array on one server. But when you send them an email or by Dropbox or copy from one server to another across the network, oftentimes the extended metadata properties get removed just because the network and the operating system doesn't know how to carry that metadata along with the file. A lot of network operating systems are not smart enough to know that, and certainly if you're moving a file that was created in a Windows environment using a DOS-based operating system to an Apple machine, which has actually got a Linux-based operating system under the hood, the extended file properties aren't supported. So just be aware of that before you spend a lot of time creating extended properties for files, that if they're going to be moved to other digital environments, then those extended properties may not survive the transfer process. Again, when we talk about directories, organizing directories to store files in, the technical term that's proper is a directory, which the sort of vernacular term is a folder. We can use those interchangeably, but folders and directories are vital for organizing different types of files in different kinds of organizational context. And then the file naming conventions for directories are very similar to those that are used for file naming conventions, but using a classified type of directory name that includes status, date, type, etc. Those are important considerations. And unfortunately, there is no one formula for creating good file or directory naming conventions, because every work environment has different requirements. So it's best to think of these as generalized principles to consider when creating a file naming convention, and then to be flexible enough when you implement a file and directory naming standard for an organization to know that you're going to have to make corrections and some changes as you find out the hidden weaknesses in your overall plan. One thing we can talk about as a general principle of organizing in a hierarchical file system by directories or folders is the concept of depth versus breadth of organization. This is actually a concept that's borrowed from library cataloging in that classification systems for books and print materials often has to consider depth versus breadth of classification. What that means is that basically we need to determine the balance between how broad our organizational scheme is and then how deep it goes. If we want an extremely detailed file organization scheme, then we would want a very deep and I'll switch to the other slide here. Very deep level of subfolders and subdirectories that create spaces to store very specific kinds of files. Deep organizational structures are great for creating very detailed organization and for classifying different types of files into very specific pigeonholes. It's not, deep organization structures, however, are not good for end-user retrieval of files. Users prefer to click as few times as possible to get to the content that they want. So the alternative to having a very deep organizational structure is to have a very shallow one that is very broad, which is shown in this slide here. So here under art we have basic genre types in art that one level of directory folders are representing. There will be a lot of files in each one of these folders if we don't subdivide under painting by acrylic and by oil and by watercolor, etc. If we don't do that subdivision, then there's going to be a lot of files that are stored in each one of these subdirectories. By contrast, the deep organization scheme has a lot of levels of organization, but there would be fewer files in each folder. So the trade-off is that with a shallow organization structure that's very broad, that you're going to be looking through a lot of individual files in a few number of folders. With the deep organizational structure, you're going to be looking through a lot of levels of folder organization, but there'll be very few files by contrast within those. Another key concept to file management, which is getting more and more prevalent and more a problem, is that many applications that we use today to create files don't just create one single file. So, for example, with a word processing application, we create one Word document, and that one document is a container for all kinds of different content. A lot of very complex applications, such as GIS applications, data analysis applications, certainly programming environments where we create software programs. These are all highly complex types of files that actually are comprised of tens or hundreds of individual files that go into making one piece of content. So, for example, if any of you have used a video editing program, you'll know that you've got the video program will usually create a project file and then you've got a whole bunch of different elements, like you've got your audio, you've got your video, you've got some special effects, you've got some slides or still photographs, and that you all integrate into one video. And then if you want to edit that video later on, then you have to save all of these elements in a particular context so that the video program can reconstitute them. Then you can edit the video, and then you produce a final video file, which is one file that includes all of the little elements that go into making the finished product. But if you start moving the audio and video elements around after you create your initial video file, then you lose the ability to go back and edit the video using the editing application. The same thing happens with GIS and research data analysis tools. Typically, we're ingesting maybe hundreds or even thousands of files into one project. Especially if you're doing, for example, a content analysis of digital documents using QDA Miner or Atlas TI or an application like that, you're actually ingesting hundreds or maybe thousands of individual files. And then using the application to sort of integrate that content together. But none of these, like these data analysis tools, don't provide a single file output which contains all of your files. Your source data is going to be in a file, basically set up in a folder structure that has hundreds of little pieces in it. So when using a contemporary application that generates complex digital output, it's important to know where all the pieces are that go into each project, and make sure that they are maintained in the proper order and context to each other, so that once you've created the project, you save it, and then you want to come back to it later, that you know that all the pieces are in the right place so that the application can see them all and can integrate them, properly, so you can do more research or more work, more video editing or whatever that you are doing. That's an important concept, because usually all of these little audio, pieces of audio, video, documents, etc., need to be contained within a single directory. And so we would need to move, put everything that I need for this project in one folder, one directory, and then move that directory around if needed so that other users can access it. There's also digital, complex digital objects that create container files that are important to note the difference between the container file and the finished file. And what I mean by that is, if we look at Photoshop, Adobe Photoshop, the container file that Photoshop creates is in the PSD, the format, and a PSD file in Photoshop can contain many different editable layers and many different pieces of editable content. Now we can merge all those layers together in a PSD file, but normally when we see PSD files, since they're not something that we typically want an end user to download off of a website, the PSD file indicates that that's a working file as opposed to a publishing file. The same thing can be said about PDF files. I mean, normally we are, you can have a one-to-one conversion of a Word document to a PDF file, but very often complicated PDF files need to be maintained in an editable working format that, especially if you're adding a form to the PDF file, or if you're adding illustrations from separate files or pages from many different files. We need to maintain those as editable objects, as opposed to a flattened, consumer-ready type of finished file. So during the lifespan of the file that we looked at at the beginning of the lecture, being able to maintain files that allow us to edit content is just as important as maintaining the finished product files that we distribute to our other users or customers. So now it's time to go back to that diagram that we looked at the very early part of the lecture. Every set of files that are produced by an organization tend to go through 3 different phases of their lifespan, and you can equivalent these phases to the youth of the file, the middle age, and then the old age of the file. But essentially, we produce files, and files are in an unfinished form, depending on the type of content that we're producing. Then we create a finished form that we want to distribute to our to people who want to use the files. And then once that content ages out, then we want to preserve the files for various reasons, posterity, or simply to maybe reuse the content at a later time. So these, I've used P words just to create an easier mnemonic, but we have the production phase, the product phase, and the preservation phase of the lifespan of a file. And these are the large, the major periods in the lifespan of a digital file. We can also think about this as the production phase is the file creation, design and creation phase. The product phase is the finished product and distribution phase of the life cycle, where we're actually sending the file out to be used by individuals. And then the preservation phase is simply where we're saving it for later use or posterity. So the three phases of the file lifespan are shown here in the top set of columns across the top of the diagram here. Each phase has essentially three stages that we need to consider. So production has three stages, product distribution has three stages, and preservation has three stages. And in short, we can call these the design stage, the creation or the authoring stage, and then the management stage. The design stage is where we get together before we start creating content to go in a file. So in the case of our personal information management, the design phase is usually doesn't take very long and might not even take any time at all. So if I know that I've got to turn in a report for this course, I can either do it in Microsoft Word format or in OpenOffice document format. And that pretty much is the design phase. But the design phase is where we figure out who's our audience, what is the type of content we need to deliver, and what are the most appropriate types of files and formats of files that we should use to accomplish this task, and then what are the quality settings of those files. Now, for a Word document, quality setting isn't as applicable, since we really don't have a low quality version of a Word document or a high quality version. But when we're talking about a mapping application or a digital photography editing application or a file, some sort of video authoring application, quality settings like resolution, whether something is compressed or uncompressed, those quality settings become very important. We need to design those into our file creation plan very early on. Now, the file creation process is where we create the production version of our content. Now, this is important if we go back to the concept of Photoshop files, where we have a PSD file that we use for actually editing the content, or we have a Word document that can be edited, and then our anticipated end file format for each of those is an uneditable format of document. So for the PSD Photoshop file, we would want to save that as maybe a JPEG image or a PNG image so we can publish that on the web and people can download it. The same thing with the Word document. If you don't want somebody to edit your paper after you've written it, then you would convert that into a PDF file. That would be our production our distribution version of that file. So we have to have editable files at the creation process so that we can create different versions of the content, and then if we have to come back and edit those versions later on, then we don't have to start from scratch. And then the file management phase is once we've created the end product for this phase of the file lifespan, then we need to be able to store them, and that's where our file naming conventions and directory naming conventions come in. So for example, let's look at the chart again here. The three stages of each phase in the lifespan of the file are represented here by this left-hand column. let me walk you through this so hopefully I'm clear about what I mean by the phases and the stages. I'm going to create a digital image and a text report that will go onto a website that the public will be able to download. I start off by thinking, okay, well, I'm going to use, in my design phase, I'm going to use Photoshop to create the digital images. I'm going to use Microsoft Word to create the text documents. I'm going to set the, we're going to use the quality settings for JPEG files, which will be our final output on the website. We're going to make sure that our quality setting in the design phase is going to be at 12, which is the highest setting, quality setting for a JPEG file. We don't have to worry about that with Word, although we will decide that we're going to use 12-point font times Roman so that it's easily readable by any user who downloads the Word document. So we go into the file creation phase now, and I'm creating PSD files for my digital images, and those have multiple layers and different editable pieces of digital content for the digital image part of the project. With the text document, I'm still just using Microsoft Word, but I'm saving different versions of the file. Now here at the end of the production phase, I have a whole bunch of PSD files and a whole bunch of different versions of Word documents that I need to save just in case I ever need to come back and edit those. Now when I move to designing the actual product for end users, this is where I'm saying, okay, now I'm ready to convert my PSD files into high quality JPEG files and make sure that I have the appropriate high resolution settings and also the appropriate compression quality settings in the JPEG file. Same thing with the Word document. I'm going to convert the Word document into a PDF 89A format, for example, that is readable by most Acrobat viewers that people have installed on their home or office PCs. When we get to the assembly part here, that's where I'm actually doing the conversion into the final product, and then I need to, in the file management phase, I need to post the final JPEGs and the final PDF files onto a public area on my website, and then I also need to keep backup copies of those files in case the website goes down or something happens and it crashes and I can't recover my public versions of the files. So here I'm creating backup copies and so forth. Now when I move to my JPEG image and my text report are now outdated. They're going to be superseded by newer versions. So in that case, I'm going to come back here to the preservation phase, and I'm going to consider what formats should I keep my content in so that years from now people will still be able to access them. Well, I've determined that I probably need to keep my Word document and I need to keep my PDF file, but I don't know if those versions are going to be readable by any software 10 years from now. So I'm also going to create a plain text document of my text report, and I'm going to save both the JPEG and the PSD file, and we're just going to have to hope that JPEGs will always be readable. There's probably a better chance of that since JPEG is an open standard than it is for a Word document to be read 10 years from now. Here's the point where I will make a plain text copy for my Word document of my text report into just a TXT file that I'll use for archival preservation. And then I'm going to store my preservation file copies, the PSDs, the JPEGs, the Word documents, the PDF file, and the plain text file on a preservation storage device that I'm going to check periodically into the future to make sure that the data stays, it maintains its integrity and can be read. So here you've got the entire lifespan of files, and hopefully that was sufficiently clear about the different phases and stages of the file lifespan. These are issues that we've already talked about when I went through that whole diagram, so I'm not going to read them over again, but these are issues of maintaining format accessibility, data quality, data fidelity, proper documentation, and etc. So you may be asking, when I'm thinking about the different phases of the file lifespan, what types of formats are appropriate for each? Well, as we talked about, in the production phase of the file lifespan, we need an editable format in which any piece of content that goes into the final product can be manipulated, updated, or changed, as needed to make the final product. Then we have the final product files themselves, and then we have long-term storage formats. So, for example, with PDF files, we might want to save a PDF/A, which is an archive version of the PDF. I'm not really fond of this standard yet. However, a lot of archive organizations do use it, but it's a very uneditable version of the PDF file that is supposed to be supposed to be accessible long into the future. We don't know. Plain text files are always great for text-based information that doesn't require formatting and etc. Text files can be formatted as comma or tab separated variable files in which you can store a table of data. Also, XML and SQL are definitely usable long-term preservation formats for structured types of data that you might have in tables or in databases. So the type of files that we use in each phase of the file lifespan matter significantly. The concepts that we need to worry about in designing files for file structures and formats for each phase of a lifespan are that we take into consideration what format do our customers or our users need to actually access and consume the information in the documents. We need to design them to be edited at a later date, to be reused and updated over time. And then we need to design, or at least take into consideration, that we can store the data in the files in a long-term accessible format for preservation purposes. So let's take a look to wrap up here. Let's take a look at the learning module this week. I do have some assigned readings which will help you a great deal in thinking about file management. And you can cross the lecture and hopefully the short introduction for the learning module off your to-do list. The major assignment, which will be due next Tuesday, is to create a file management specification document. Now, I do have a template posted on the learning module that you can use. But essentially, the file management specification is going to be a set of rules that are implemented at each phase and each stage. So we have 3 phases, and each phase has 3 stages. Those are the rules governing the types of applications used to create files, the formats and the quality settings for those files, the naming conventions of those files, the organizational structure of storing those files for each phase of a lifespan. And basically, I want you to pick a set of files from a discipline that you are familiar with. So you can pick any subject discipline in the academic world. You can pick any professional discipline that you are familiar with. And I want you to build a specification document that lists all of the rules for managing the files for an imaginary organization that you work for or that you're consulting for. Now, the template has a number of different suggestions as well as the previous slides from the lecture. But basically, we want a document that is of good enough quality that you could use this to help train new employees to your organization on how files are going to be managed within the organization. Think of this as a team document or a group document that you would be passing around to make sure that everybody who works in whatever organizational venue that you choose is able to use that as that specification document as a reference for how to do their job when they are planning to create files, planning to create content, and then getting ready to distribute it to customers or end users, and then at the point where it needs to be retired and preserved. This is a very helpful exercise in terms of thinking about how multiple information workers in an organization are going to have to work together to make sure that the content that they create is accessible and retrievable and in the proper format for creation, distribution, and archiving. I've also got a short tools and methods assignment where I would like you to pick two file management tools. One off of the list that I've posted on the learning module that you can simply download. And the second is I would like you to search the website CNET, that's CNET.com, and find a second tool that you can download and install that deals with organizing, renaming, or converting individual files so that it makes it easier to work with large numbers of files in some sort of organization's file server. Then I'd like you to post your tools and methods report on your two tools, and the instructions are there on the learning module, to the discussion forum for this week. And then I'd like you to comment on your classmates' tools reports by next Friday. So the file management specification document, need to upload that to the assignment Dropbox by Sunday. Strike that. You need to upload that by next Tuesday. That's 9/24. The same thing with the tools and methods assignment, due by next Tuesday. And then the discussion postings are due by next Friday. So as always, have a good week. And if you have any questions or need help, you can email me, call me, or drop by the office. This week is going to be a little busy, so there might be a little delay in my getting back with you, but I'll do my utmost to get right back with you. Then I want to also remind you all that I'm going to be out next week. I'm leaving on Friday, and I won't be back in town until the 23rd. Now, I do anticipate having internet access, and I will do my utmost to get next week's learning module posted for you before I leave. But my response time, if you need help, might be a little slow. Next week's assignment will deal with actual data processing using Microsoft Office. So if you need help, there are certainly on-campus resources to help you if you can't get a hold of me or if something, if I'm delayed in responding. But I will do my utmost to respond and help you out while I'm away. But I'll be in Europe, so there'll be definitely a time lag between being able to respond to you. All right, let me know if you need any assistance, and have a good week.